Today we're going to look at an 8.5 review. So this means that we're going to look at finding missing pieces of some triangles. Notice that in problem number 1, we have two triangles. We have two triangles in this picture. Notice though, I have parallel lines here. That's what these markings are. Okay, and so remember, when we have parallel lines, we are going to be able to get similar triangles. And the reason why we're going to be able to get similar triangles is because we're going to be able to use the idea of getting congruent angles within these triangles. Notice that this angle of DEH is going to be corresponding to angle F. And that means they're congruent because when we have parallel lines, this takes us back to first semester, when we have parallel lines, corresponding angles are congruent. Remember, corresponding means that they're on the same side of the transversal, but one is interior and one is exterior. It's the same idea over here. This angle of DHE is going to be corresponding to angle G. And when we have parallel lines, corresponding angles are congruent. Both triangles share this angle D in common. So an angle can be congruent to itself by the reflexive property. And so we basically know that the triangle DEH is similar to the triangle of DFG. So notice I was very careful when I was naming my letters. Angle D is congruent to itself, so that's why D's are put in the same spot with my triangles. Notice that where I have it marked for E and F, those need to be in the same spot in my triangles because those are marked the same, and the same with the H and the G. Okay, so when I have similar triangles, that means the ratios of corresponding sides are congruent. They're asking for us to find DH, so I'm going to call that X, and they want us to find EH, I'm going to call that Y. All right, so these are the two sides we want to find. One of the sides, DH, we're going to be able to use the side splitter theorem. So that tells me that because I have these parallel lines, notice that the parallel line EH is splitting up the side DF as well as the side DG. When it splits it up into a proportional split. So that means that the left side, we can do DE over EF. That's the big side being split, so we got to set it up as a ratio. That means we get to set that equal to then the other side being split, DH over HG. Okay, notice that DE is the top portion of the left side, DH is the top portion of the right side. Notice those two segments are on the top of my proportion. So we have to be very careful there. But with this proportion, I can now plug in my numbers. So 8 over 2 is going to equal X over 3. So now I can go ahead and I can cross multiply, or technically I could simplify down the 8 and the 2. But either way, we should be solving for X, which is going to represent the side of DH. So 2 times X is going to equal 3 times 8, which is 24. And then I just have to divide both sides by 2. X, which once again remembers DH, is going to be a length of 12. So there is one of my two answers. Now, I needed to have similar triangles to find then the side of Y, because notice Y is the side of my triangle that isn't being split up, okay? It's helping form the split. So I needed to have those sides, or I needed to have those triangles written out so then I could set up a proportion of all the corresponding sides. So notice that DE is going to be corresponding to DF because the first two letters of the first triangle are going to go over the first two letters of the second triangle. That's going to equal EH over FG. That's because the last two letters of the triangle have to go over the last two letters of the second triangle. But then that's going to equal DH over DG. Notice D and H are the first and the last. D and G are the first and the last. So I had to put those together. So this proportion right here, I can now plug in numbers that I know. I know that DE is a length of 8. DF, this is where we have to be careful. DF is this entire side. That's made up of 8 and 2. We have to add those together. So really, that's a length of 10. Notice that EH is the side we want to find. I'm going to call that then the Y. FG is given to us as 14. Once I've seen that I made up a proportion where there's only one unknown, even though that last ratio is true, it's not really needed any further. I just need to set one fraction equal to the other, but I only want one unknown variable. So just like the last part of this problem, I'm going to cross multiply. So I'm going to multiply the 10 and the y together to get 10y. And then I'm going to multiply the 8 and the 14 together to get 112. I'm going to divide both sides by 10. That will get me y, which once again is that side that I want of EH. And so 112 divided by 10 is going to get me 11.2. And that would be my other answer. Okay, so this problem deals with the side splitter theorem, which is what helped us solve for x. And then the fact that we have similar triangles helped us solve for y. All right, so here's our next problem. Here's our last problem. We're going to find the perimeter of the triangle FJH. Okay, notice to find the perimeter of that big triangle means I want to add up all the sides of the triangle. Notice how that would be the side EH, which I technically already know because I can add the 7 and the 3 to get that side to be 10. Notice that another side of that triangle would be FJ. The only problem is that there's a variable here. I need to find what x is, so then I know what that entire length is. And then notice that the last side of the triangle is JH, and that's a side that I don't know either. So right now, to find the perimeter, which means I want to add the 3 sides, I only fully know one side. So we've got a little bit of work cut out for us. To find the x, notice that that is being created because that segment GK is splitting up the sides. So we're going to use the side splitter theorem. So notice that FH was being split. That got split up into 3 and 7, so I'm going to make that a ratio. I put the 3 on the top and the 7 on the bottom, which means if I go over to the blue highlighted side where it's being split, I have to put the 6 on the top because that is lined up with the 3, okay? Those are on the top of the sides being split. The x is what I want to find. That's the bottom portion. Okay, so I'm going to use that information now to cross multiply. I'm going to multiply the 3 and the x together, and then I'm going to multiply the 7 and the 6 together, which gives me 42. And so then all I have to do to get the x is divide both sides by 3, and that's going to give me a length of 14. So now that I know that x is 14, I can find the entire length. So once again, that highlighted yellow side was me adding 3 and 7 together. Now I want to add 6 and 14 together, and so that's going to give me that side to be 20. So the last thing I need to find is my highlighted green sign. I want to find y. So in order to do that, I want to think about similar triangles because once again, notice that we have some markings that show that we have parallel lines, which means that there is this angle and this angle congruent because they are corresponding angles. This angle and this angle are congruent because they're corresponding, and then angle F is congruent to itself. So essentially, that small triangle of FGK is going to be similar to the bigger triangle. Now, F is congruent to itself, so I have to keep the F's in the same spot. G is marked with 1 marking, and so is H, so they need to go in the same spot. And notice that K and J are marked the same, so they need to go in the same spot. Okay, so because I have similar triangles, I can set up ratios of corresponding sides. So FG, first 2 letters, that goes over FH, first 2 letters. That's going to equal GK over HJ FJ, because those are the last two letters. That's going to equal FK over FJ. So those are all three sides, and their corresponding and ratios of corresponding sides are equal when we're dealing with similar triangles. So now I'm going to start plugging in numbers that I know, and I want to come up with two ratios where one of them has an unknown. So FG, that's a number, that's 3. FH, well, we added those numbers together to get 10. Notice that GK is what was given to us, that's 9. Notice that HJ is what I'm trying to find, that's Y. So once again, that means that for me, I don't really need that last ratio there because now I have 3 numbers and 1 unknown. I can cross multiply and I can solve for Y. So 3 times Y is 3Y. That's going to equal 10 times 9, which is 90. I'll divide both sides by 3 to get that Y equals 30. So if Y is 30, now I have all my sides. I can find the perimeter because I'm going to add 10, 20, and 30 together. 10 and 20 is 30, 30 and 30 gives us a perimeter of 60.